Good morning, dear students. See, in the last class, we have discussed about the data set. Okay, what is the data set? And then we have seen what are the attributes and the measurement. And then we have seen the important topic, that is types of attributes. In that, we have got totally two main categories here, that is categorical attributes and numeric attributes. Again, in that, in categorical, we have got nominal attributes and ordinal. And in numeric attributes, we have got interval and ratio. Okay. So, and again, one more classification of attributes is based on the number of values. Again, in that we have got three different kinds of categories, that is discrete, okay, then continuous, and then asymmetric attributes. So till this we have discussed in the last class. Okay, now coming to the next topic, that is about the types of data sets. Okay, so before studying the types of data sets, we shall understand what are the main characteristics or features of a data set. Okay, so what are the characteristics or the features which are exhibited by any of the data set if you consider? Okay, so first characteristic of a data set is dimensionality. Okay, so as the name says here, dimensionality is nothing but number of dimensions. Okay, so how you are going to measure this dimensionality? See, dimensionality is measured by the number of attributes, okay, that is present in the objects. Okay, so that number of attributes which are present in the objects, that is possessed by the objects in the data set, see, that is called as dimensionality. Dimensionality is nothing but dimensionality of a data set is the number of attributes that the objects in the data set possess. For example, say if you consider a student data set, see if you have got total that is six attributes. Okay, so like student name and then USN. Okay, and then you got the gender. Okay, date of birth. Okay, then we have got the address and marks. Total, if you got six attributes, see all these attributes, they constitute the dimensionality of the data set. So dimensionality of the student data set will be 6 here. Okay, so the number of attributes that the objects in the data set they possess, that is called as dimensionality. Okay, so if you consider a data set, okay, that has got a less number of dimensions, so it will be somewhat different if you consider a data set that has got the medium or high number of dimensions. See, the data set which has got the less number of dimensions, it will be qualitatively, the quality of the data will be somewhat different compared to the data set that has got a medium or large number of dimensions in the data. Okay. So now, see, as I explained in the that is first chapter in this module, see, suppose if you increase the number of dimensions, it is going to consume a large amount of that is space to store that data. So if you increase the number of dimensions, it is going to consume a more amount of space for storage. Okay. So that difficulty which is associated with analyzing the high dimensional data, so it is called as curse of dimensionality. See, already about this I explained in the first chapter. See, curse of dimensionality is nothing but, see, as you keep on increasing the number of dimensions or the attributes of the data, it is going to consume a lot amount of storage space for storage. So that is called as curse of dimensionality. So in order to remove the curse of dimensionality, say we are going to reduce the number of dimensions which are present in the data. That is called as the dimensionality reduction. Say if you reduce the number of dimensions or if you remove the number of attributes which are present in the data set, okay, so that technique is called as dimensionality reduction. So that we will study in the topic of pre-processing. Okay, so this dimensionality reduction, see, it is one of the pre-processing technique where we will be removing some of the dimensions in order to reduce the storage space. Okay, now coming to the second characteristic or property is, that is sparsity. Okay, so sparse data and dense data. I hope that everyone has heard this word, that is sparse and dense. Okay. So if you consider the sparse data, see, this sparse data is related to asymmetric features. So in the last class, I explained what is the that is asymmetric attribute. See, asymmetric attribute is an attribute where we are bothered about the presence of values. That is, only non-zero values will be considering for processing. Okay. So this sparse data, see, it is related to the data sets that contain the asymmetric features. Okay. So in case of asymmetric features, see, many of the attributes will be having zero values, and only 1% of the attributes will be having non-zero values. See, in the 100% attribute values, okay, so in that, see, only 1% of the attributes will be having that is non-zero values. Some value will be stored in those attributes, and 99% of the that is attribute values will be zeros only. Okay, so such kind of data is called as a sparse data. So sparse data is the data where see, most of the attribute values will be zero, and only less than 1%, approximately less than 1% attributes will be having non-zero values. Okay, then what is the advantage of this sparsity then? See, obvious advantages. See, if you are bothered about only non-zero values, okay, so then you can only store the non-zero values in the memory, and it can be easily and efficiently manipulated or analyzed. Okay, so it is going to consume less amount of storage space here. So storage space required for storing this sparsity of data, so it will be less here, because very few attributes will be having non-zero values, that is less than 1% of the attributes will be having non-zero values. So we can easily store that in the memory, and we can easily manipulate or that is make changes to that data. Okay, and see, as I said, see, it is going to significantly save the that is computation time and the storage. So if you have got the less amount of data that has got non-zero values, then you can easily and efficiently perform your operations, analysis operations. So it is going to reduce the computation time, and also storage space will be less. Okay, and many of the data mining algorithms, see, they are going to work well for this sparse data. If you got the sparse data instead of dense data, so many of the data mining algorithms can efficiently work on such data. Okay, so this is about the sparsity. Now coming to the third one, that is resolution. See, resolution is will be different for one data compared to the other data. See, each data will be stored at different resolutions here. So in case of images, you might have observed, see, resolution of the each of the images will be different. So in the same way, see, the data will be having different resolutions here. Okay, and the properties of the data will be different at different resolutions. See, if your data has got the low resolution, then its properties will be different. And if a data has got the high resolution, that properties of the data will be different. Okay. And also, say, as I explained in the last class, in case of data mining, will be extracting the patterns here, useful patterns from the data. So these quality of the patterns is also going to depend on the level of resolution of the data. So what kind of data resolution you have got? Say, based on that data also, this quality of the patterns is going to depend here. Okay. So suppose if the data is very fine here, say if you got a high quality of data, then it will not be possible to that is extract your pattern, because it will not be visible in the high or very fine resolution data. Okay. Suppose if the resolution is very low or very coarse, then also, say, it is not going to display the patterns here. So you need to have a resolution which is in between, that is in between the low and high. You need to have a medium resolution. Okay, so this is about the characteristics of the data. So see here, so first one is dimensionality. See, dimensionality is nothing but it is the number of attributes that the objects in the data set possess. So how many number of attributes the objects have got, that is called as dimensionality. Okay. So if the data set has got a less number of dimensions, then the quality of that data will be that is different compared to the data set that has got the high number of dimensions. Okay. And see, suppose if you have got a large number of dimensions in the data, then it is going to consume a lot amount of storage space. So that problem which is associated with the high dimensional data, that is called as curse of dimensionality. As you increase the number of dimensions, it is going to consume a lot amount of storage space. That is called as curse of dimensionality. So in order to that is solve this problem, that is curse of dimensionality, we'll be reducing the number of dimensions. Okay, so that technique is called as dimensionality reduction. So we shall study this topic under the pre-processing concepts later in this chapter only. Okay, so second one is sparsity. Say, sparsity is nothing but, see, this is the feature or the characteristic that is related to that is asymmetric attributes, where we are more bothered about the presence of values or the non-zero values. See, if you consider the asymmetric attributes, see, many of the attribute values will be zero. Approximately 99% of the values which are stored, they will be zero. Only less than 1% of the attribute values will be having non-zero values. Okay. So since in the asymmetric attributes, we are bothered only about the presence of values or non-zero values. Okay. So we have got some of the advantages here. Say, since we are storing only non-zero values, we can easily store them and we can easily manipulate them to perform our operation. And one direct benefit of sparsity data is, say, it is going to save your storage and also it is going to reduce your computation time. Okay, those are the advantages of sparse data. Okay, and many of the data mining algorithms, see, they are going to work well for the sparse data. So if you have got less number of that is attribute values, so with such kind of data, see, this many of the algorithms, they can easily work. That is also one of the advantage. And third, that is characteristic of the data set is, that is resolution. Okay, so we will be having data at different levels of resolution here, and the properties of the data, see, they are also going to differ at the different levels of resolution. So low resolution data will be having different properties compared to high resolution data. Okay, so and also the patterns which you're going to extract, that is also going to depend on the level of resolution here. Say, suppose if the resolution is very fine or high resolution, if you got a high resolution data, then you may not be able to find the pattern here because it will not be visible. It may be that is present in the noise area. Okay, so because of that, you will not be able to find the pattern. Suppose if the resolution is too coarse or if the resolution is too low, then also, see, the pattern will not be visible. So you need to maintain the resolution in the medium range. Then only you will be able to find the pattern. Okay. So this is about the three different characteristics of a data set. Okay, now coming to the types of data sets. So see here, mainly we have got three different kinds of data sets here. So first one is, that is record data, and second type is that is graph based data, and third one is ordered data. Okay, so these are the three different types of data sets which we will be studying here. Okay, so now coming to the first one, record data. Okay, so I'll show you the example here. You can understand that. So see here, so this is the example of a record data. So as you all know, so what record is, so record is nothing but it is a data object. So collection of data objects, they are going to constitute a record data. So your, that is DBMS table. Okay, that is one example for record data. So how the data will be stored here? See, the data or the table, see, it will be having a collection of records. See, collection of records are nothing but rows here or the tuples. Okay, so that is collection of records are nothing but data objects here. And each of the record, if you consider, see, it will be having a fixed set of fields here. That is these fields or the columns. See, they are called as attributes of the record. Okay. So a record data is nothing but it is a collection of records. See, this is one kind of a data set here. First kind of a data set is record data. So in case of record data, see, the data will be, data set will be a collection of records here. If you observe, it is a collection of records here. We have got total here in this data, we have got total 10 records here. So each of these records are nothing but they are data objects here. And if you consider each of the individual records here, see, each individual record, say, it will be having a fixed set of fields here. These fields or the columns, they are called as attributes. So attributes are nothing but they are the fields here. Okay, they are, that are going to describe the records. Okay, so one of the example how the data will be stored in the record data is, it will be stored in either flat files or relational database tables. Okay, so flat files are nothing but your Excel sheet files you can consider, or even in case of that is your doc file also, you can create a tables. So in that you can save your record data, or else your DBMS tables. See, that is also one of the example for relational, that is relational database table. That is also an example for record data. So the best way to store the that is records is that is your relational database tables. Okay. So this is about the record data. So see here, see in case of record data, see the data is data set is a collection of records here, and each of the records it will be having a fixed set of data fields here. Okay, so these fixed set of data fields are called as attributes. And then how the data will be stored here? See, record data will be stored either in flat files, okay, normal files, or it will be stored in relational databases. Okay, so the best way to store the record data is that is using relational databases here. Okay, so that is one of the convenient place to store the records here. Okay, so now coming to the types of record data. So see in this we have got three different kinds of record data. So first one is transaction or market basket data. Okay, so I will show the example here. So see here, see this is example of a transaction or market basket data. Okay, so this transaction data, see, it is one of the type of record data here. It is one of the example of a record data. See, as you know, so in case of record data, we will be having a collection of records, and each record will be having its own set of attributes or the fields. Okay, and now this transaction or market basket data, see, it is one of the special type of this record data. Okay, so if you observe here, see each record, see it will be having a set of items that is bought by the customer. Just see here, see if you look at the record one, see bread, soda, milk. Okay, that is one of the transaction here. So it contains a set of items that is bought by the customer. In the same way, second one, beer and bread, so that is also a list of items that is bought by the customers. Okay, so this transaction data or the market basket data, so it will be collected at the grocery that is point or the stores. See in your grocery stores. Okay, so this kind of data will be collected. Okay, so here see the set of data here will be nothing but it is the set of items or the products which are purchased by the customer while they are doing the shopping. Okay, so when they will be doing the shopping, they will be purchasing some set of items. Okay, so that items or the products will be placed in a transaction or market basket data. Okay, so and each of the individual product is nothing but it is a item here. Okay, so this is, for example, bread. It is a product which is bought by the customer. It is nothing but item. Okay. So this is called as a market basket data. See, the reason for calling this as a market basket data is because this is the data with respect to the products which is bought by the customer. Okay. See here, each record, see it is going to correspond to what is the product or the item that is bought by the customer at the grocery store. So only it is called as market basket data. Okay, so here each record, say it will be present in a form of list of items. Just try to remember that each item will be present in a form of list of items. It will be stored in a form of list of items. So even we can represent this data. Okay, so as that is asymmetric attribute also. So where we will be indicating whether the item is bought by the customer or not. Even you can use the binary attributes. Okay, so where you can represent whether a customer has bought the that is item or not. So if the customer has bought the item, okay, that will be represented as 1. Okay, if he has not bought the item, that can be represented as 0. Okay, so here also if you observe, say since the customer has bought the bread, it is represented here. Okay, suppose for example, if the customer has not bought the diaper in this transaction, see it will not be indicated. That is, presence of values will be important here. So only it can be represented as asymmetric attribute here. Okay, so this is one kind of a record data, that is transaction or market basket data. Okay, so second type of that is a record data is data matrix. Okay, so a data matrix is nothing but, see again, see here the data objects will be having that is a collection of data here, and all these data objects, see they will be having same set of numeric attributes. See if you observe here in case of data matrix, say projection of X load. See, all these are numeric metrics here, distance and then load, thickness. See, all these attributes will be numeric attributes here. So here the data set will be a collection of records, or the collection of data which where all of the records will be having same sets of fields. Okay. Suppose if you got a same set of fields, then you can represent this data in a multi-dimensional space. So you can model that data in the multi-dimensional space. See, where each of the dimension, see, it can be represented using the different attributes here. Okay. So such a kind of data will be represented in a form of that is M cross N matrix here. So here M is nothing but the number of rows for each of the object. Okay, and then N is nothing but the number of attributes. Okay. So data matrix, you know, right? So matrix is nothing but, say, it will be having M rows and N columns. Okay. So since here, see, all the collection of objects, they have got the same set of numeric attributes. Okay. So we can represent this data in a form of a multi-dimensional space. So see here, we have represented this data in a multi-dimensional space. Okay, so and each of the dimension, say, it will be represented, if you consider each of the dimension here, say, it will be represented using distinct attributes here. Okay, and here the set of objects, see, it can be represented in a form of M cross N matrix here. See, M is nothing but number of rows. Okay, and N is nothing but number of columns. So here the data has been represented in a form of, that is, matrix. So here we have got M rows and N columns. So this is the second type of record data. And third type of record data is, that is, document term matrix. Okay. So or it is also called as sparse data matrix. Okay. So that is the third kind of record data. See, in case of sparse data matrix, okay, so again, it is a special type of data matrix here. Okay, so sparse data matrix, it is a kind of a data matrix here. Okay, so here in this, see, the attributes of the objects, see, they will be of the same type and they will be asymmetric. Okay, so all the attributes, see, they will be having the same type here. Okay, so I will explain you with the help of example and understand it. Just remember this one. See, sparse data matrix, see, it will be having that is a set of attributes here. Okay, and again, all of these attributes will be of same type and they will be asymmetric. Asymmetric means that we are more bothered about the presence of values here or non-zero values. So one of the example of sparse data matrix is your transaction data. So this transaction data, see, it is an example of a sparse data matrix, because where we will be worried more about the presence of values here. So it can be represented using zeros and one values here. Okay. So one more example is the document data. Okay. So document data, see, we can represent in the form of a vector here. Okay. And each component of this vector will be having the number of that is times the term is going to appear in the document. So if you observe here, see, this is the document matrix, that is a document data. So it has been represented in a form of vectors here. And if you consider the each term here, so if you observe, see, this is a term that is appearing in the document here. Term is nothing but words. So words which are appearing. So if you consider first one, team, and then we have got coach, okay, and then play, ball, score. See, all these are the terms which are appearing in the documents here. See, in this, we have got three documents. Okay, so in the document term matrix, we are representing the data in a form of a vector here. And each of the vector is going to correspond to the, that is how many times that a word is appearing in the document. For example, team is appearing 3 times in the document one. And then coach is appearing 0 times, and then play is appearing 5 times in the document one. In the same way, in document 2, team appears 0 times, and then coach 7 times, play 0 times. Okay, so each document has been represented in a form of vector here, and the values of the vectors, so it is going to represent how many times the terms or the word is going to appear in that document. Okay, so this is the third type of record data. Okay, so I'll repeat that again. So see here. See, in case of record data, see, the data set will be a collection of records, and each of the record will be having a set of data fields or the attributes. and this record data will be stored in the form of flat files here or the relational database tables. Okay, so this is one of the example for record data. So where we have got a collection of records and each of the record has got the sets of fields. So this has been stored in the form of a relational database table here. Okay, so now coming to the types of record data. So first type of record data is transaction or market basket data. See, transaction data, so it is a special type of the record data. And here each of the transaction, if you see here, so each of the transaction will be having a set of items which are purchased by the customer. Okay, so the set of items which are purchased by the customer during the shopping, okay, that has been represented as a transaction here. Okay, and then if you look at the products here, see, products are nothing but those are the items which are bought by the customer. Then why it is called as a market basket data? See, the reason for calling it as a market basket data is because it is going to constitute the list of items that are bought by the customer while making their shopping. Okay, while shopping, what are the different items which are bought by the customer? Okay, that has been represented here. So only it is called as market basket data. Okay, so even this is one of the example for asymmetric attributes data, because here we will be representing the item only if the item is bought by the customer. If trade is appearing here, so it is represented here just because the customer has bought. If the item is not bought, then it will not be represented. For example, diapers is not bought in the transaction one, so it is not represented. Here also we can represent the data using zeros and ones. Okay, so only it is an example of asymmetric attribute. Okay, so now coming to the second type of record data is data matrix. Okay, so here the data objects which is a collection of data here. See, all of the data objects will be having same sets of numeric attributes here. Okay, so if the attributes have got the same set of numeric attributes, okay, then we can represent that data in a multi-dimensional space. Okay, so for example, say this data, see, it has been represented in a form of matrix here. So where we have got total, that is m rows and n columns. In this data, there are total m rows and n columns present. Okay, so now in this data, say, rows are nothing but the data objects and columns are nothing but the attributes here. Okay, so this is second type of that is record data. And now coming to the third type of record data is that is a sparse data matrix. The third type of data, the record data is sparse data matrix. Okay, so in case of a sparse data matrix, see, again it is a kind of a data matrix only. Okay, so in which see, all of the that is attributes, they will be of the same type. So if you observe here, see, all these attributes, they are of same type, that is they are of string type. Okay, because they are representing the words here. Okay, and they will be asymmetric here. Asymmetric means that they will be more worried about the presence of values here rather than non-zero values. Okay, so now see, one of the example for this is transaction data. See, transaction data is also one of the examples for sparse data matrix. See, where we can represent that data in a form of that is zeros and ones. Okay, so one more example is the document term matrix or the document data. That is also one of the example for sparse data matrix, because see, here we can represent each document as a vector here. Okay, and the component of this vector will be the words here, and the values of the that is vector, they are going to represent how many times that word is appearing here. So each of the document in a document data, it has been represented in a form of that is vector, and each of the vector, say, it is going to correspond to that is value of the vector is the thing, but it is going to correspond to how many times the word appears in the document. So if you observe document one, say, the term team is going to appear 3 times. So in the same way, okay, so win is going to appear 0 times in the document one. Okay, so this is about the third type of that is record data. Okay, so now coming to the that is second type. Okay, so you do one thing. Okay, so you can log out and re-log in again. Okay, because already, so we are left with only 5 minutes. Okay, so you log out and log in. I will explain the next step.